planned for, obviously. We'll have to rectify that tomorrow in this afternoon's sessions. Ken McLeod just told us that cryptography is not the solution we think it is, or maybe it was Stian who said that actually. Anyway, here's Werner Koch to perhaps give us another perspective on it, or at least give us some more details about what cryptography is and how it works and the state of the unions. Please welcome.
Thank you. So this is not really about details of cryptography. This talk is just a memory dump of what I know of projects using, well, basically end-to-end encryption, and in particular OpenPGP. Am I speaking loud enough? Yes. Okay. This talk is about end-to-end encryption, and I looked up on Wikipedia what end-to-end encryption means, and they have a very long abstract in the front where they explain it. It's 100 words exactly. So, but we can do it much easier. So my definition is all data exchange between the user-operated devices, keyboard things, is encrypted and optionally integrity protected. Integrity protected means that nobody can just change parts of the message and render them render them unreadable, or inject some other parts into it, even an encrypted message. So that this is what I understand on end-to-end encryption. Usually this is done using plain encryption and a digital signature, but there are other ways to do this. This end-to-end encryption is mainly used for mail. I call it mail or not email, but it's definitely this thing you write on your computer. Chat protocols like Jabber, or they call it XMLP, and all these others, and phone conversations. This is where we all want to have end-to-end encryption. We know that modern protocols for your phone use end-to-end encryption. Some do this for chatting. Phones, it's basically they only protect metadata to the server, so there is no real end-to-end encryption for phones. There are exceptions like ZRTP protocol, but so I concentrate on the mail stuff, and let's see why I think we need end-to-end encryption. For encryption, we need a key, a private key, which is secret. This private key must be somehow protected so that nobody else can get access to the key and this way decrypt the message. The problem now is that if we would use servers to do all the encryption for us, can we trust the servers? But in most cases, so maybe not for all of you, but in most cases the servers are other people's machines. So there's at least one administrator, or usually a group of administrators. Maybe there are users who can do local exploits. So you can't really trust the server. If the server should encrypt stuff for you, then it goes encrypted. Examples for this is StarTLS, so the encryption between the mail servers. This is something which we do on the server. It's good to do this, but it's not enough. So, and we can't trust the servers if they act as a middleman. We, of course, can trust the servers if they deliver the content, or if we use them remotely, if we SSH into the server. But that is not what is end-to-end encryption. Yeah, so we can't use any servers for this if the server does the actual encryption. The solution is quite obvious. We need to keep our keys under our own control. This is commonly done if you put the keys onto your desktop machine, or on your laptop, or on your phone. Phone is already a bit risky these days, but well, by definition, this is the last device, the device of the user. So this is the end-to-end encryption. If you want to keep your keys really protected, you use a smart card, which is a separate device. So end-to-end encryption is, well, is it old, is it new? I don't know. In former days, we had these restricted transport media, which means that King A and King B had some courier who was sent out to deliver a message. This could be seen as kind of end-to-end encryption if you don't consider the courier done. Later we had wires connecting to capitals, for example. This is kind of a transport medium which was safe until you could find crocodile clamps there to wiretap. Later, people realized that they need to do encryption, but it's a lot of it used to be a lot of work to encrypt the documents. So with code books, for example, so they established cipher rooms. And the cipher rooms, they were clerks, are just going encrypt and decrypt messages. So this is not anymore end-to-end encryption because there are many other people, the clerks who are doing the actual encryption, can look at the plain text. To mitigate this, for very confidential stuff, people used super encryption, so they sit on their own desk, encrypted the stuff, and they gave it to the cipher room for regular encryption then. The first time it was possible to do real end-to-end encryption was with PGP2, so in 1992, I would say. At that time, mostly for mailbox networks, bulletin board services, and the early internet. So you could do this end-to-end encryption because you had your own device there. It's not really true, but many Unix people had a terminal, but if you had a PC, you could do your end-to-end encryption then. That was PGP2, and it was good, you could use it. Fine. Meanwhile, we have all these web mailers, which is back to the servers. You do all your encryption, if you do encryption at all, on the server. That's not sufficient, in my opinion, because too many people can get access to your content. Let's quickly talk about online versus offline protocols. It's often said that we should just drop all this email stuff and use online protocols for chat and things. They are really needed, and I like to use Java, or we like to use IRCs for quick communication. The problem is that you need an active network connection if you want to do run one of these protocols. So there's no way, if the internet is dead, it doesn't work. Real advantage is that you can do negotiation of the protocol, and you can update the protocol online. So it's much easier to deploy such software and a new protocol if it is an online protocol. So because the peers are really connected. And this also means that there's a higher attack surface, so you can't do this, what we call air gap, so that you have a separate laptop, which is highly secure, and you take a floppy disk or some serial wire to connect it to the other machine. This is called an air gap, but it's for real high confidential stuff. One should use this as one measure. This is not possible, obviously, with online protocols, because there is a gap between them. The offline protocols like SMIME and OpenPGP do not require a network at all. So you could just encrypt your files, your data, put it onto a lorry, and just let it drive to the other end, and it takes off then and decrypts it. So there's no network required, so the data can be at rest. Actually, it's often used also for backups and later for restore. So there are many options to use offline encryption, like it's also called store and forward systems. Disadvantage is that it's very hard to update the protocol. For example, if you're a Unix guy, you know the tar format, the tarball, which is basically the same for 40 years. And we still are able, using our software, to decode, unpack a 40-year-old tarball. That's the same thing as with offline protocols like PGP. We can still decrypt encrypted mails from 20 years ago. So it's hard. You have to be very cautious if you want to update the protocol to not lose all access to the old data. But this also means that you can use it for high security tasks because you can just offload it to a separate room, a cipher room, whatever, which is well protected, do the encryption there, and then carry it the encrypted part out and send it over the internet or by whatever means. So let's see. The interesting stuff about things has been shown by Snowden 2 years ago. Meanwhile, partly forgotten. Some bugged systems, by which I mean systems which have a backdoor. There is the Crypto AG in Switzerland, founded by a former US friend of US cryptographers from the US Black Chamber. They produce crypto devices, which are definitely bugged, have a backdoor, whether it's a technical backdoor or whether they wrote manuals which didn't explain it correctly to do this. So the effect, how to safely use it. And the effect was that all these crypto AG devices sold to countries not friend of the US or Switzerland maybe, were easy to decrypt everything you could do with it. There are several examples for this. You can read it up on Wikipedia. And so that's a lot of stories. So definitely, it's like an early NSA thing. And then we had some people know the crypto wars. There was this 40-bit thing. So the US restriction on export of cryptography restricted cryptography to 40 bits because they assumed they will be able to crack this, a key of this short key. There was one exception for this. This was Lotus Notes, which got permission to use a 64-bit key for exporting. But to get this permission, they had to leak 26 bits. So effectively, they only had 38 bits then left. The NSA said to this that is a workload reduction factor. So not really secure. The Lotus Notes exported, not exported, so which you could buy in the US had before no backdoor, maybe probably. Some may remember the NSA key in Microsoft software. We don't know whether this is all true, but after the Snowden revelations, it might be that there was really something to this NSA key, that the NSA had access to Microsoft Windows and could update parts of their crypto stack. And then the really interesting thing, which has already been mentioned this morning here in this room, is the RSA safe library, which is a library RSA forced Phil Zimmerman to use for the early PGP. If he wants to use it, then they wouldn't claim that they have a patent on it. So the RSA safe library was not used. So there was a version which could use it, but nobody used it. And we've seen that in 2004 they added a random number generator which was clearly designed to have a backdoor. So it was it's a simple backdoor, and this thing is the RSA safe library is used in all products by RSA Incorporated. So this has nothing to do with the algorithm, hardly, but it's a company. It's a company which also runs this large RSA conference. So for close to 10 years, they produced software which had a backdoor. The backdoor is random number generator, which means that you can crack the key easily. So these systems are not used for. Other failed systems are S-MIME. S-MIME and X509 is probably known by all of you. The interesting thing is that since 2013 I've seen no more requests to work on the S-MIME part in UPG, or very rarely. A few people still use it, but everybody lost trust in it. The main thing is that S-MIME is connected to the public key infrastructure, which is broken. It's basically the same thing as we have with the web browsers. The web browsers started recently, a few years ago, to add band-aids to fix the system so that you could do transactions on the web and be sure that it's not, that it's still safe. So this whole thing, it does not really work for a couple of reasons. It's still fine if you have a controlled infrastructure. So if you have a large company and you have all your keys or your certificates under control, you can still use this stuff, and it's used by governments a lot. And in the setting, it works, it's okay, but you can't allow other root certificates except for those you are in control of. Example of another failed system is the D-Mail, or D-Email, which is a German mail system not connected to the internet. It's a central re-encrypt system, and with a strong identity proof. So you have to go provide a government-issued document to get this address. And the idea was that the administrations could send you a mail over the email, which is the same as a regular letter, and it should save costs for them. It's expensive because you have to pay for each mail, but that's not the real problem for the companies who wanted, for insurance companies, for example, who want to send out mails that they thought, it's cheaper for us if we can do it this way. Interesting is that the Federal Commissioner for Data Protection in Germany said at the start of this system that okay, it's nice, it protects something, but if you have any confidential data which needs data protection, you need to do additional end-to-end encryption. So basically, he said this whole system is void. It does not fulfill any purpose except for, I don't know. Recently, last half a year ago, so they added an extra OpenPGP layer. It's not possible. So there are a lot of questions regarding this, whether it's still legal to use this for legal documents. And they use Mailvelope, which is OpenPGP software, for this nice thing, but the whole system is anyway broken and actually dangerous, because if you even register for an account there, you are legally obliged to read it every few days, because they could send you something and then you have seen it and then you know about this. If you are that's basically does not work. So just that, and it's not connected to the internet, so that's anyway. More or less failed system. So I mentioned Silent Circle because many people tell you, you could use Silent Circle. In particular, Phil Zimmerman always says, email is dead. You use Silent Circle. You can also assign attachment to this. Silent Circle is what you need to do. But Silent Circle is no store and forward system. They used to have a mail part for it, but it has been shut down a long time ago. And advantage is, from technical point of view, it's very good. It's a solid system. The developers, so I would trust these developers. So I know some of them, and they're cool and smart guys. So it's okay. And you can even look at the source code, but it's not free software. You can't build it yourself. And the old system also, because it's apps for mobile phones, it relies on automated updates. So if the NSA says, oh, you have to do some thing that we can read the message of them, it's possible that they send you an update for your app with a backdoor then. You can check this. Phil claims that he is going to sell this system to government agencies, so they don't, they would get into a conflict if they want to do this, to backdoor the system. So, well, I don't think it will work very good. Better systems, these are all systems which work on OpenPGP. One is Kali Open, which is a unified messaging system, so for SMS and email and with crypto. They are currently building it. It's a French organization or French people who are doing this. They're supported by GandhiNet, so it's a large internet provider in France. And what they do is basically they want to get back to this old internet where you had a lot of mail transfer agents, so mail servers, which are all interconnected. These days we only see 3 or 5 MTAs. Every second one is Google, and they say, oh, Microsoft, and that's it. And they want to have a more decentralized system, and all with encryption enabled and key lookup and so done that. Enigma might be known because if people tell something what to do, if you want to write secure mail, the press always says, you use Thunderbird and install the Enigma plugin. Enigma. So it's, we have different other plugins for other mailers, so but Enigma is just one example, the most prominent one. It's probably the most used one by non-geeks, maybe also by geeks. But it has a lot of flaws. The problem is that there used to be only one developer who does this in his spare time, and this developer has a real-time job and has to take care of no development department, and so it's entirely understaffed. So I'm paying a student now to help out with fixing a few bugs there, but it needs more support because it's known, it's good, it works, except for all the bugs it has. Bugs meaning that it's too easy that you accidentally send off plain text. But they are working on it. But yeah. Google end-to-end is, everybody heard about this. This is a really smart project. They have good ideas how to do it. It's well researched. They have a very good code base for this. It will, I don't know when it will be launched. I believe the idea is that Google needs this system to sell their mail services to companies and not for the regular Gmail users. So the system itself is very solid. They actually waited for GNU-PG to implement to do a release of with ECC support. They're doing exactly the same ECC algorithms and what we do in GNU-PG. So it's nice. So at some point in time, we will probably see a lot more ECC keys. ECC means elliptic curve cryptography. It's the new RSA. I doubt that there will be a huge adoption by the majority of Gmail users because it cannibalizes their business models for Gmail. There's also Keybase IO, which is not which is a kind of replacement of for the key servers to find the keys for encryption. What they do is quite clever. They connect the keys using your social media networks. Quite clever, but do we really want that? We want privacy and not just that we need to have a lot of connections and friends on Facebook. And so to be sure that this is a key. Mailpile, led by Yanni and Smari McCarthy. It's a web mailer. It's a web mailer, but a web mailer running on your own machine. Yanni has, I think last year, I had several talks about this here at FSCONS already, and it's probably known by long-time attendees of FSCONS. It's quite portable, and it has encryption built in. So it's a core component, encryption, and looking up and making it easy and having a nice user experience. They released the first version, but it was not good enough, so they have a new plan on when it will be released. But again, here it's understaffed. I think currently there's only Vianney working on this, and yeah, the advantage is they don't have a business model. This is an advantage for them, so they are driven by business needs, but by needs to protect privacy. But the other side of the story is that they don't have enough money for this. Mailvelope is, I mentioned it with DML. It's an extension for browsers to do OpenPGP. So you can use it for webmail, and the problem is where to store your keys there. So they are also accessible by the browser, so they are not that safe. Street is kind of a larger project on how to make the experience using OpenPGP mailers better. So I think 3 years ago, 4 years ago, I gave a talk here about Street here. So it's basically what's kind of extension to make lines. There is a public tender from the German BSI, the Federal Agency for Information Security, to implement parts of this, or some parts of this. It has not yet confirmed which company or which group has won this tender, and we'll see. I think it's we're working in GNU-PG on part of this. For example, we have implemented this TOFO part in GNU-PG and several other things which will be needed to deploy such a system. So we are working in the GNU-PG project. We're working on parts of this. Another thing is Whiteout. It's a startup company in Munich who does basically the same what Google does. So they are a mail provider with mailboxes, and they provide a key infrastructure, and they wrote a new mail application in portable way, so it's available for the browsers and for mobile phones. It's open to use by the regular key servers from today. And it's similar to Mailvelope, so the storage of private keys is also questionable. Okay, let's see what my take on what will prevail is. If we are looking at business infrastructure for mail, I'm pretty sure that Google end-to-end is something which will be used in the future. The same is for Whiteout, probably for people who don't want to have their data in the US. So it's a German company. I don't think that Kali Open will work. So tools for the web. I think Mailvelope is a nice thing currently to do something with webmail, but we need a more integrated solution, and that would be something like Mailpile. And so the classic home user tools, so not only home users, but those classic mailers, which are not web mailers. I think Enigmail, as soon as we have implemented some of these key concepts there, we've put more effort into Enigmail. Enigmail can be something which makes it much easier to write and read encrypted mails. I think Keybase.io is, well, the web of trust thing of today. So you, instead of key signing parties, you do your social graphic thing there. It's nothing which will foster development of encryption use. So conclusion is that business-to-business mail will eventually move towards end-to-end encryption, more or less completely. That home users will encrypt more of their mails, but I doubt that it will ever be more than 20%. And pluggable devices, which may be based on MailPile, have a good chance to change things. So it's just you buy something for 30 euros or 20 euros, plug it into your network, and you have your web server with your webmail and thing, and it all works, and they connect automatically to others, whether using the existing mail infrastructure or another peer-to-peer network for connection. This is something which has a future, in my opinion. However, these non-business-driven projects, they need your support, or the support of people, and by developers. So they also have problems to find developers doing something. This is important. If we don't get enough finances to pay the developers, we won't be able to do encryption for everyone. That's the experience from the last 20 years. Okay, that was my overview of the state of end-to-end encryption. If you have any particular questions to this, I would answer them. I could also tell you something about GNU2G, current state of development, if you have questions regarding this.
So I have one question. Coming back on the side of key, I think, the OpenBGP standard has the same problem. That is, as described in IRC 4880, if I want to send a mail to to send an encrypted message to someone, and basically what I would like to have is a flag on a key. I think you had a draft on that a couple of years ago. But a flag on the encryption key, that the owner would set that flag, and then it would promise that they would keep the key offline or keep it secure somehow. So that I would have, for instance, two encryption key, one not very secure, stored on my laptop for everyday usage, and another one for super offline communication.
Okay. So your question is. Yeah, what is your question?
My question is, is there any plan to have that integrated in IRC 4880?
So the question is more it's a very specialized use.
I realize,
for offline.
Yeah.
So, I don't know. Just write to the working group about this. I don't think this is a major problem for acceptance of for end-to-end encryption. You want to have it more secure for your use case because you know a lot about this.
No, but it's exactly the same. Exactly what you described. There are like the two drawbacks of mail-envelope and which was the other one. Whatever. Like I don't want. What you said was that okay, you have the browser has access to the private key, and that's. Well, you seem to feel not very confident about it, and then the next step would be I don't feel very confident with my laptop having, any process on my laptop having access to the key. That's the natural next step to me.
Yeah. Okay. Yeah. Definitely. I think that smart cards are a very good idea to protect your keys, but the problem with smart cards is that you have to pay for them. And pay for a reader or something. You have to put 20 euros. Yeah, you need about 20 euros to use a smart card. That's nothing an average user would spend just for trying out whether encryption is useful or not. So it must be free of charge first.
And then they need 20 hours to install themselves.
Yeah.
To read that card.
Yeah. I have a thought about the idea of pluggable devices with mid-file or similar infrastructure. I've heard that idea quite a few times over the last 5 years. One thing that I fear with that is that before we have such a device that we trust and think this is well implemented, we can use this, most mainstream users will only have their phones to tether for internet. Because that's a development I've seen with plenty of people I know, even who are interested in technology, that they don't have a broadband connection at home anymore.
Okay.
And then the idea of everyone getting a pluggable device kind of falls on there's nothing to plug it into.
So the question was whether it's realistic to assume that there is something you can plug in the device to your and connect it to your access point, because you assume that soon UMTS or LTE connection will prevail the internet, so there is no more wire coming into the house where you can plug something in. Yeah. So well, that's a question whether you want to own your data or not. So whether you put it onto this cloud on the other people's machines, or whether you want to have it at home or under your own control.
Of course.
So sure, you could just you could also rent a server somewhere or some other place where you can plug in your box and run it there. Yeah, I have no solution for this.
No, I was just a thought that how will these timelines go? Because that's another development that is kind of contradicting it. But yeah.
So what's the difference of having something plugged into your network physically and having just a separate connection to your email server and having a broadband connection always available, always connected? I mean, that's what the telecompany is looking at, right? Having massive amount of hardware being connected all the time, Internet of Things. So what's the difference of having a physical line to your home and having a telephone operated connection to Internet?
Of course, there is a difference, but I'm wondering what, if this use case will match that infrastructure. Everything is of course possible, but I'm just...
I don't see the difference in the...
So if there are no more questions for Werner, let's thank him again. And close this session. The next session starts at 4:45.